Hey guys, welcome back. So in this video we're going to look at threads. So what is a thread? Well, a thread is a way to execute multiple things at the same time in your program. So normally your program follows a sequential order, right? So I might do something like this. It's x equals 0 and y equals 1, and then I can print out x and y, right? So if I do this, then my program is going to start at line 6, and then it's going to do this instruction right here where we create a variable called x and set its value equal to 0. And then we're going to go to line 7 where we create a variable named y and we set its value equal to 1. And this works fine for the majority of our programs. But in some cases, you want to use parallelization, which is basically using threads. So, for example, modern computers, they have not just one core, but they have multiple cores. So with these cores, you can do multiple tasks at the same time. So while one core might be reading input from someplace, you might be processing that input on another core, and then you might be sending it out to users on another core or thread. So now let's say that we have a large list of numbers, and we want to sort that list of numbers. Actually, let's say that we have multiple lists of numbers. So let's say that we do this. We're going to create a couple of array lists, and inside each array list, let's just store a double. And we'll call this R1. This array list, we're just going to initialize it like that. And we're going to create another one called R2 is equal to new array list. And we could keep going, right? So let's say that we had maybe 10 of these guys. Well, an easier way of doing this is to instead do something like this, where we have an array list of doubles. So we're just going to have a bunch of array lists, and we'll just call these random num lists is equal to new array list. Now our goal is to sort every single, our goal is to sort each of these lists that are stored inside of this larger array list. So we have a bunch of lists, and then we have we have a bunch of lists inside one main list, and then we want to sort each of those individual lists. So the first thing we're going to do is we need to initialize some random data. So what we're going to do first is we're going to, let's say that we want to create 10 of these guys, right? So we're going to do for int I is equal to 0, I is less than 10, and I++. We're going to do random num list dot add, and we're just going to add a new array list. Okay, so it's pretty straightforward. Now what we're going to do is we're going to go through our main list and then fetch each list. So array list double, let's see here, we'll call it non-init is equal to new array list. And now what we're going to do is we're just going to create 100 random numbers. So we're just going to do j is less than 100, and we're going to do non-init.add. So now to create a random number, we can just use this static function in the math library called math.random. And what this does is it returns a random number between 0 and 1. So we're going to scale that number up, so it's between 0 and 100 now. Okay, so now we've randomly we've initialized this main list with a bunch of sublists, each of which have a bunch of random numbers. So now let's just print this out just to make sure everything works properly. And okay, so that didn't quite work because these guys are still empty. So why would that happen? Well, let's step through our program, and then that'll give us some kind of idea for what's going on. So let's see here. We're going to go through, and this should happen 10 times. That's pretty straightforward, so let's just skip over here. So now what's going to happen is we have this array list. Oh, okay, I see. So that was silly of me. What we're doing is we're not creating a new array list. We're fetching it from our main list like that. Random num list dot get at index I. So remember, we have our main list, and then we're fetching it at index I. Now let's run, and okay, we have a bunch of values. And yeah, it should be 1,000 different values because we have 10 different lists, each of which contains 100 items. Okay, so that's fine. And now what we could do is to sort all of them, we could we could do something like this. We could go through our random num list and then do something like collections.sort array list, and then we could run. And if we were to run, it would take quite a bit of time because we're sorting a large number of, or I guess it wouldn't take too long because 1,000 numbers, it's really not very much for a computer to sort. But here, let's just print it out just to demonstrate that they're being sorted. So now notice that we're starting at the lowest number and we're working our way upwards for each of these lists. But you know, suppose we decided that we wanted to sort 10,000 numbers inside each of our lists. Now we have 100,000 items we need to sort, and that was still pretty fast actually. Let's see here. So what's still running? Yeah. Okay. So that took a little longer because now we had so many more numbers to sort, and you can see that if we had maybe like if we increased it by a factor of 10, it would take even longer. And in fact, my computer is freezing up right now because there was just so much input on that page, or output on that page. Okay, so we could sort it like this, and we could do it sequentially, where we sort one array list, and then we wait a little bit of time, and we sort another one, and then we wait a little bit of time, and then we sort it, and then, you know, each sort takes a little bit of time, and then we go through the entire list. But suppose we could do this in parallel. So we sort one of these lists, right? And then we use the parallel functionality of our computer so that we can sort another list at the same time we're sorting the first array list. So what if we could sort maybe like 10 of these guys at the same time, or 4 of these guys at the same time? Well, surely that would speed up how long it would take to sort all of these guys, right? So let's measure this. What we're going to do is we're not going to print out the list anymore. We're going to print out how long it takes for our program to execute. So what we can do is, let's say that we store the start time up here is equal to system.current time millis. So all this does is it just takes the number of milliseconds since the epoch, or the time in 1970 that we discussed a few videos back. And what we're going to do is we're just going to find the difference of this. So we're going to say that program took, and then we're going to say system.current time millis minus the start time. So we're going to find the difference in time, and we're going to just say milliseconds. And okay, so now we need to put some parentheses around here because the order of operations was a little ambiguous there. And now let's run. And okay, so it took 51 milliseconds. Now let's let's increase it by a factor of 10, and we'll see that okay, it's increased by a factor of, so what is that? It was 283 divided by 51, so by a factor of 5.5. Okay, so that is fine. So now let's look at how to use threads. What we're going to do is we need to open up a new thread for each list that we want to sort. To do that, we say that we want to create a new thread. What this is going to do is we need to first specify like what kind of action we want inside each of these threads. So we're basically, you can imagine, opening up a different kind of process, or another process that's going to run concurrently with our main execution. So let me be a little more clear about that. What we have is we have this main method right here, right? So what happens when your program starts? When your program starts, it enters this main method, and we're inside what's called the main thread. What that means is that we have just one thread and everything happens sequentially. Every time we open up another thread outside of our main thread, then what happens is, you can imagine you have your main thread and it's going downwards, like maybe like this. So here's our main thread, right? And now what we're going to do is we're going to open up a new thread outside of our main thread. So we're going to open up a new thread, and what that's going to look like is, imagine that now we're going to do something like this. So now we have a new thread, and it's going to continue, going sequentially in order and doing whatever it needs to do. But our main thread is also just going to continue, doing whatever it needs to do normally. So now our new thread, it might, process numbers, it might do something else, but then eventually it's going to finish. And when it finishes, that's when that's when it, so like once it's finished executing the contents of whatever is inside this run method, then it's going to die basically. Okay, so now all we're going to do is we're just going to take this collections.sort method and then we're going to throw it up here. And let's see here. So now what we need to do is, well, okay, so everything's going to run inside of this runnable right here, and it's going to run. And so we're going to stay in this run method for each of the threads we're creating. Okay, so now let's do two things. Let's actually call the thread we're being returned. We'll call it thread T, and let's print out something like finished sorting list. And what we need to do now is we need some kind of indication of the list that we're currently sorting. So we want to store 10 total lists, right? So what we can do is we can do something like int list number, and we'll set it equal to 0. And then on each iteration of our loop, we're just going to do list num ++. And now, if we wanted to access this list num variable inside of this anonymous inner class, we need to make it final. Here, I'll explain what I mean in just a second. Plus list num. If we try to do this, we're going to get a compiler error because just generally, whenever you're working with an anonymous inner class, we need to declare this as final. So then we would do something like final int index is equal to list num, and then we can put it down there. And okay, so now we've created our thread, but we need to actually start it. So to start it, we do t.start, and we could run this and it would work, but there's just one more thing that we're missing that's not quite right, and that's basically this last statement right here where we're printing out how long our program takes. Because we're starting a new thread, what's happening is that our program is going to finish executing, but these threads are still going to be running in the background because they have to process all of this input. So we can test this out really quickly, and we'll see that even though our program finished, it finished really quickly, it finished in 5 milliseconds, we still have output following the end of our main method, and that's because these threads are still running in the background. Notice that each of these guys, we're sorting 1,000 elements now instead of 10,000. Also notice that they didn't finish sorting sequentially. So it's not like item 1 finished and then item 2 finished. It turns out that item 1 finished sorting first, then item 0, then item 7. And this could be due to a variety of factors. Maybe one of the lists was maybe more nearly sorted than the others, and so it didn't take quite as long. Or maybe worst case scenario, the list was I don't know, in like reverse order, and so that accounts for the poor behavior of list number 2. It finished before some of these other guys, even though it was even though its thread was started a tiny bit earlier. Okay, so how do we fix this program issue? What we can do is we can instruct our main program to wait until every single thread has finished executing. And the way we do that is we call this join method right here. So what this does is, let's run it, and then then I think it'll make it a little easier to understand what it's doing. So it did do the correct output, it did do what we wanted it to do. But what it's doing is it's basically waiting until it instructs our main thread. So we're in our main thread whenever we start this main function. Imagine that, right? So we're in our main thread here, and then we construct this new thread. That's what we do down here. And then we start it, so we get to this arrow segment right here. What this t.join method says is it instructs our main thread to basically wait until this thread has finished executing. Okay, so this one's gonna wait. So what this is doing is it's going to say, okay, as soon as you get to this segment right here, pause this main thread. So we pause this main thread, and then once this thread has finished executing, then continue on. So this is going to kind of do what we want, but there's still a problem. Imagine that this is our first element, this is the first list that we're sorting. So this is the first list that we're sorting. The index is equal to 0. We fire up this new thread, and then we start it. So as soon as we start it, then we're going to go inside this t.join method, and what that's going to do is it's going to freeze the main thread. So it's going to freeze the main thread, which means we're not going to go into the next iteration of our loop. Instead, we're going to wait until this run method inside of this original t thread has finished executing, and then we're going to start iterating over the next item. So to prove this, let's add some print statements. Println firing new thread. So when we hit this print statement, that we're going to be starting this new thread. When we're over here, when we're above the join statement, what we're going to be doing is we're going to say maybe about to, or let's just say waiting for thread to finish. And then after the join statement, we're going to say println, let's see here, thread finished executing. So you can imagine the join statement, remember, it pauses the main thread. So our main method, it doesn't do anything until this thread that we've created finishes executing. And if we run this, we're going to get quite a bit of output. First, we're going to fire a new thread. Once we fire the new thread, we're going to wait for it to finish, and we're going to get this line right here where it says finish sorting list number, just because that's what's going to happen after we finished with one thread. And then we say we print out this line 46 after the join finish. The join stops blocking the main thread, right? So then we get these 4 lines of output. Then we're going to fire a new thread, and then we're just going to do the same thing over and over. So that's not any better than our original approach, because this is kind of sequential, right? What we're doing is we're firing up a new thread, we're waiting for it to finish, and then we're just starting a new thread and we're waiting for it to finish. That's not what we want. We want it to be like, okay, we fire up one thread, then we fire up another thread, and then another thread, and then we wait for all of them to finish. And then, we want to be able to say the program took however many milliseconds. So just for a baseline, we can see that when we did it sequentially, it took about 13 milliseconds, like that. So instead, what we can do is we can do something like this. Let's create an array list. We're going to create an array list of threads. So these threads, let's see here, these are going to be instead of joining down here, what we can do, let's take these guys, and we can do join threads dot add t. So we're going to add the thread to t, and after we've finished starting up all of our threads, then we're going to iterate over all of them, and now we can say, okay, now we're going to wait for it to, now we're going to wait for each of the guys to finish executing. So this is different because what we're doing is, again, we're creating the threads and then we're starting them, and only after they've already been going after they've started going on their way are we going to call this join method on each of them. Now if we run it, okay, so you see that we fired up all of our new threads, and now we have all of these print statements, and our program took 6 milliseconds, which is quite a bit better than the 13 milliseconds before. But that's not really statistically significant, just because we have so few test cases and we only ran it like once. So let's add a lot more items to each list. So let's say that we want, I think, 100,000. So they are yeah, that's 1,000,000 items. So 1,000,000 items per each of our 10 lists. So that's going to be 10 million items, and it took about 1,126 milliseconds, so about 1 second. And let's just so maybe if we commented this out for now, just to see how long it would take, let's comment this out, and let's use our old approach where we just iterated not over that guy. So we want to iterate over here. I'm going to put this guy below here, so now our for each is going to auto complete really easily. And then what we're going to do is we want to collections.sort, we want to sort each array list. And okay, so the last one took about 1,126 milliseconds, and this one might take, well, let's see how long it takes. So it took about 3 times as long, and let's just we can run this another time actually. So we'll run it one more time using this approach. 3,600 milliseconds, so again about 3 times as large, pretty consistent. And let's Control Z this back to our threaded code. So okay, so we have 1,000,000 items, and we have our multi-threaded program. And so, yeah, again, it took about 1,000 milliseconds. Notice that that's about a 3 times performance increase, and it's probably because my computer, it has multiple cores, and so you can run these guys efficiently together, and so you're able to sort all of the lists a little quicker. Note that we used array lists in this example, but generally when you're working with multi-threaded code, you should kind of stray away from using array lists. We're going to get into why that should be, or why you should avoid using array lists in multi-threaded code in a couple of videos from now, but it worked in our case because we weren't modifying each list from multiple threads. So once we created this thread, we were just sorting it, and we weren't really, we didn't have another thread that was modifying what we were sorting at the same time. We would have run into issues if we had multiple threads and each thread was modifying each list maybe while it was being sorted, or yeah, while it was being sorted. That would lead to quite a bit of problems. Maybe if we were adding items while it was being sorted, stuff like that. But we weren't doing that, and so it worked out fine. Anyways, we're going to get into some of these threading issues in the next videos. I'll see you guys then.